In this video, I'm going to explain how to use algebra to solve systems of equations. For this video, there are two important questions. The first is, how do you use algebra to solve systems of equations? The second is, if you solve a system and there is not just one solution, what does that mean? This video is going to focus on algebra, but it's also important to remember the connection that this algebra has to the graphical representation. So if we look at a system of linear equations, that's going to mean two lines on the graph. And the solution of that system will be where those lines intersect, that point. Some lines don't intersect at one point. For example, parallel lines never intersect. And two lines that are actually the same line don't have one point of intersection, they share every single point. We'll see those a little bit later. For now, let's look at one example. Negative 5x minus 7y equals 11, and x minus 2y equals negative 9. The best method to solve this system of equations is substitution. The reason for that is that this x in the second equation doesn't have a coefficient. It's already alone, which makes it very easy to manipulate this equation to solve for x. So what that process looks like, we're going to take that second equation and try to get x by itself on one side of the equation. We want x equals and all the other terms on the other side. So we can do that by moving this 2y to the other side of the equation, and we'll get x equals negative 9 plus 2y. Now that we've isolated x, we can look at why this method is called substitution. The reason for that is because we're going to substitute x with this expression we've just found is equal to x. So in that first equation, negative 5x, we can replace that with negative 9 plus 2y because that's equal to x. After we do that, we can go ahead and just distribute and use algebra to solve this now single variable equation for y. Now that we've solved for y, and we found y equals 2, we're not done. Remember, this is a system in two variables, so we still need to solve for x. But we can do that by taking this value we found for y and replacing it into any of the equations in our system. So we can replace y with 2 and use that to solve for x. Now we found x equals negative 5, so we've solved for x, we've solved for y. How do we write that answer? Remember that the solution of a system of linear equations is the point where they intersect. So we're going to write this x and y as a point. In other words, parentheses, x, comma, y. So negative 5, comma 2. The next method is called elimination. In this system, we could use substitution because you can see in that first equation the x is alone, but we can also use elimination because you might notice both equations have a term 8y. Because those terms are the same, they can easily eliminate one another by subtracting one equation from the other. So we'll do the first equation minus the second equation. X minus 7x is negative 6x. 8y minus 8y is 0, which we don't have to write down, but we can. Negative 15 minus negative 9 is negative 6. And then we can go on to say negative 6x equals negative 6 and x equals 1. Once again, we're not done here. We found x, but now we need to plug this back in to x in any of our previous equations and use that to solve for y. So in this example, we can't use substitution because all the terms have coefficients. And we can't use elimination because none of the terms have the same coefficient. So what we have to do is change one or both of these equations so that we get an equivalent system that's easier to work with. So if we try to get 6 and 7 to become the same coefficient for x, that's going to be kind of ugly. We're going to have to get a coefficient of 42 because that's the least common multiple of 6 and 7. But 2 and 4, their least common multiple is 4. So if we can get that 2y to become a 4y, then we'll be able to use elimination. The way to turn that 2y into a 4y is to multiply it by 2. But of course, we can't just multiply that term by 2 and leave everything else as it is. That would be a different equation. If we multiply both sides of the equation by 2, then we'll maintain equality and we can keep that equation in our system. Now, if we use a positive 2, then we'll have a positive 4y, and we'll need to subtract one equation from the other in order to eliminate that y. But if we use a negative 2 and distribute that across both sides of the equation, we'll save a step because then we'll be able to just add the two equations, and negative 4y plus 4y will still eliminate. So now that we've got the 4y and negative 4y terms, we're ready to use elimination. And we can do that by adding these two equations together. So 7x plus negative 12x is negative 5x. 4y plus negative 4y is 0, so we don't have to write that. And 8 plus 12 is 20. Now we've got negative 5x equals 20, x equals negative 4. And now the last step is to take this x equals negative 4, plug it back in for x in any of the equations from previously in the system, and solve for y. You might notice that for the 3 examples we've looked at so far, they all had one solution, a point where the two lines intersected. So for this example, the place where those two lines intersect is at the point negative 4, 9. For this next system, go ahead and pause the video, try to solve it yourself, and then see what happens. You might need to change the equations a little bit to make an equivalent system, like in the previous example. So something kind of weird happened. We got 0 equals negative 10, which of course is not true. Remember, we're looking for the place where these two lines intersect, but 0 equals negative 10 isn't true. What this means is that these lines never intersect. They're parallel lines, so there's no solution to this system of equations. We could look and look for a point of intersection forever. We'd never find it. That's what this wonky answer means. There's no solution. Now for this last example, once again, why don't you pause the video and try to solve it yourself. So here we've got another kind of interesting answer. It's different. This is not a false statement, it's true. 0 equals 0, but we don't have an x and we don't have a y, so we haven't really found a solution like we expected to. 0 equals 0, that's true, and it's true no matter what the values of x and y are, but it doesn't tell us where these lines intersect. So what this means is that these two equations actually represent the same line. They occupy the exact same set of points, meaning if we're looking for where they intersect, or rather where they share points, there's an infinite number of solutions. These two lines share every point. So these last two examples are special cases, infinite solutions and no solutions. Now to recap, remember we had those two questions from the beginning of the video. How do you use algebra to solve systems of equations? And if you do so, and you find that there isn't just one answer, what does that mean? I hope that after watching this video, you feel like you understand those questions and you can answer them. If you're not sure or you have more questions, please let me know. Thank you so much for watching and have a great day.